Hello, everyone. This is the from Jackson University Digital Media Program. I'm here to present my Digital Media 540 project. So let's share screen. So the project I have made is using reinforcement learning in Unity games. Talking about games are made of explicit rules, and it is easy to modify and build challenges. And knowledge of learn from game can be easily transferred into other areas. So game has been used, game are good environments for testing and developing AI. And also machine learning being used in games to improve gaming experience, but it needs big data. And big data is controlled by tech giants, and those are their tech giants' private assets. So individual developers and small firms have no access to big data for them. For them, it's very hard to train good AI agents. So using reinforcement learning to develop games machine learning agents is very helpful because it does not need data. They're talking about reinforcement learning. There are 5 essential elements of constructing reinforcement learning: state, action, reward, environment, and policy. State is all the situation that agent can visit, actions are all the action that agent can take, perform. Reward are the numerical value given to the agent while the agent is in the state or after he have taken the action. Environments are made of sets of rules for the agent to move and also to interact with. And policy are mappings from particular action states to particular actions. The goal for the reinforcement learning agent is to form a policy that optimize the reward with given state, action, reward environment. The reward is very essential in guiding the agent. Think about training dog. You have to give the dog treat after the dog have performed the good per action. So that the reinforcement learning algorithm will emphasize the action that triggers the reward. But there's a problem in the reinforcement learning regarding reward, which is called delayed reward. That is the action that contributes the most to the reward probably not getting the reward, because the action getting the reward is the action that directly triggers the reward. So and this will result in the inefficient training and also performance, and it getting worse. It is getting worse on the sparse reward situation. For example, in my project, this is the early stage of my project, and the agent will get a +1 reward while the agent reaches the final target. But with all the possible situations, possible places the agent can visit, it is impossible for the agent to reach the final target. So we need intermediate reward. And intermediate reward, which is the sum reward while before the agent reached the final target. For example, when the agent getting closer to the target while it's on the brink, it will get some numerical values as a reward. This is called credit assignment. So credit assignment will need expert domain knowledge. So it could be biased. And with biased knowledge, the agent will only learn to perform the action that the developer wanted to perform, rather than it develop its own strategies. So the key issue of reinforcement learning is to find a way to improve the learning process regarding both efficiency and accuracy on the sparse reward in complex environments. I have several related works to share in paper reward predictions based credit assignment for reinforcement learning with sparse binary rewards. So I all have developed a way called the key action detection. And they will find the key action that contributes most to the reward and reassign the reward to the action. And in paper, information sobriety approach to curiosity-driven reinforcement learning. Still, and all proposed perspective about how for the agent rather than only exploit the knowledge you learn, they have to explore the environment and maximize the learner's predictive power. In papers that grab micromanagement with reinforcement learning and coherent transfer learning, Shaw et al. Proposed the efficient state presentation to deal with the many states that the agent can visit. And regarding the sparse reward, they provide some more intermediate reward functions to guide the agent. And they use the transfer learning to accelerate the training process. In paper, action guidance, getting the best of sparse reward and shape reward for real-time strategy game, Huang and Tana proposed method collection guidance, which is they design the auxiliary agents with shape reward, and the main agent that learns only on the sparse reward, and the main agent will getting the advices from the auxiliary agents every time when you perform an action, adding, and also the manager will decrease the possibility taking the advice from the auxiliary agent while the game getting close and to the end. So I have a project, which is I made I trained my own reinforcement learning agent in my own game in Unity. So let's see my blocks. Excuse me. Project. At the beginning of my project, I've explored many ways to perform reinforcement learning in games, and I found the Unity ML-Agents package that the Unity provided is very helpful because it is very easy to use, and it helped the game developers to implement reinforcement learning into their games. And it provides some examples. So let's see how do you set up the Unity ML-Agents. First, you have to download it from GitHub, and then you have to have the Python environment and some Python packages. After download it, I use Anaconda to set up the virtual Python environment. And then after you have installed it, and then I experienced example from the ML agent, which is called 3D Boss. And this is in Python, you have to start the training. And then you have to click button play for the Unity to play the game. And while it's playing, the Python will learn how to achieve the final target, the goal. And this is the learning process. And then while the learning is finished, I moved the learned neural network model into the agent, be called behavior parameter component in the model space. And then you click play, you'll see the agent will behave. And then I started my own project. So my own project is called I Wanna Be Suffering. This is a game I created last term. And this is a Mario-like game that you can jump, and you can go left and right. If you have bricks, you can jump higher on bricks. This is the agent. And then I have made the environment, I have made the agent, I programmed the agent. And let's see. How it works. So you can jump left and jump right. You can second jump while you are in, while you have jumped once. And this is final target the agent has to reach. So totally I have 6 training processes. And the first training, the first day of training, turbo result. I have totally 6 actions for the agent to take. For the movement, it has 3, which is go left, right, and also stop. And for the jump, the agent can jump twice, which is the second jump, and also not jump. At this training, I have 6 observations for the agent, which is the location of the agent and the location of the target, XYZ. And also one the ray perception sensor 3D, 2D. Okay, the first day of training, I only had 50,000 steps, very too few, and result in terrible result. And then I modified it a little bit. I provide an intermediate reward, which is while the agent getting closer to the target, it will get some reward applied to it. Still, a terrible result. Let's see the training process. This is student training. And I had 10 agents running parallel. Okay, let's see second training. For second training, I modified the rules a little bit. On ground to determine whether it should be given the reward. On ground, which means that every time when the agent on the brick and getting closer to the target will get some reward. And add 3 more observations, which is on ground, boolean value, second jump boolean value, direction, numerical value. This is the configuration for this training. And this time also failed. And third training, only thing I modified is the configuration file, and the result failed. Means that the agent never reached the final target even once. Fourth, as 2 more, I modified the reward. Add 2 more conditions, 2 more possible reward the agent can have, which is while the agent getting closer, absolute value distance closer to the target, also on the ground. Also add while the agent getting closer on the x-axis and also on the ground. And also at the y-axis, also on the ground, getting closer to the target, will get some rewards. And so this time training, not even still failed because the agent never reached the final target even once. So in the fifth training, I modified it a little bit more. I have have to be remember that all the changes have to be made in the prefab rather than in the game objects. In the fifth training, it also failed. There's no doubt. But in the sixth training, this one is the successful one that I have. In sixth training, I have modified reward system a lot again. Also, I have modified the environment a lot. I found out that the environment has to be designed to offer more and more possible situations in order to let the agent learn different situations so that the agent can find general knowledge to complete the task. So this is the fixed update. I moved all the reward system into the update function, and I also added a curiosity list. Curiosity list. This is providing the reward to the agent while every time the agent explore a new brick, you will get some reward as the curiosity reward. And also for the reward, as I said, every time when the agent getting closer to the target, you will get some reward. Every time the agent getting closer on the x-axis to the target, and not on the brick getting some reward, and also y-axis as well. And also, I have this. This is giving the reward to the agent every time you're getting closer absolute value closer to the target, and also getting negative value while you get away from the target. This is the episode. On each episode begin, I randomize the position of the target and the agent. The agent will be randomized along this line, and target will be randomized along this line. So, in the environment, as I said, I fulfilled fulfilled the whole environment with all these different bricks, because I found out that sometime in the previous training, the agent will getting here and getting here, but never reach the here to reach the target, because I think that the agent never learned to jump left and just this long and getting reward in the previous steps. So I add all these bricks to offer the more and more possible situations for the agent to learn to interact with. And this time, turns out I was right that the agent reached the final target and reached the convergence. And in each episode, from the beginning, it have to take like 5,000 steps, and at the end, it only took like 250 steps to finish one episode. And also, let's see the result. This is done by the agent. You can see the agent performs the actions with no useless actions. Goes very fast. So, something I learned from my project regarding designing the intermediate rewards. You have to think about what kinds of information the human can get, like the position of the agent itself and the target, and position of bricks. And while you see the agent getting closer to the target, you will get some reward. You know, it is correct, but you have to design those to the agent to let the agent know. But also, what should be allowed to the reinforcement agent, because you can let the agent to know something that humans don't know. And thinking about different types of reward will result in different learning. As I said, I have several different types of reward. Absolute distance, while on the ground getting closer, and x-axis getting closer on the ground, y-axis getting closer on the ground, and also getting closer absolute value will get some positive reward, and getting away from it will get a negative reward. And also a curiosity list, that is very important. And you also have to think about the percentage of each type of reward you given to the agent, because the agent will learn the most percent take the more percentage of the reward, or the more reward the numeric value you get, you will think that is more important than others. And also configuration file will impact the learning deeply. regarding the environment, you have to design the environment that the environment should allow randomness of setting up each episode, because with more and more randomness, like I randomized the location every time the episode began of the randomized target, and also randomize the player, because it will provide more situations for the player, for the agent to learn. And this you provide you have to make the environment with more situations, like I said before. So with enough different situations, the agent can learn more general knowledges, and also this can improve the learning speed. So this project, I mean, I learned a lot from training my own agent in reinforcement learning, and also learned a lot about the Unity ML-Agents package. And I think that manipulating the reward system is very interesting. I think about this, about the shape reward, how to manipulate reward, how to improve the reinforcement learning by giving what kind of guidance to it, could be the interesting, or could be my future focus on my master thesis. And thanks everybody. This is my project. And I hope in the future I will share more videos about reinforcement learning and in the games. Thank you, everyone.